This is a first order differential equation. We'll look at second order, that's when you have a d2y by dx squared. And we will look at systems of differential equations, that's when you have two of them. But this is just a straightforward one. And there's only one method, which is separate and integrate. So the first thing we're going to do is solve the differential equation. And that means integrating it with a plus c. That's going to be called the general solution. But then they've given us a bit of extra information that helps us find c. So let's do that. So look at this dy by dx here. This needs to be separated. So this dx here is bound to end up on the right-hand side. And the dy is inevitably simply going to stay there. That will always be the case because you will always see a dy by dx. So the task is to move all the x's to the right-hand side and all the y's to the left-hand side, and that's always the case. Let's move this x and y over. This is like a form of reverse cross multiplying. I'm just going to swap them. That's really nice, and I'm nearly done now. I've got the y and x separated. Now is the time to separate the dy and the dx, and I'm simply going to multiply this dx up. So that's really nice. And I've deliberately done it this way. You'll see a lot of students write it like this. And that's not technically wrong, but I think it just leads to confusion. So separate your dy and always put it at the end. Separate your dx and put it at the end. So when you've separated, you always immediately integrate. There's no line that looks like this. We put the integral symbol in. And now the dx and dy that we've been kind of treating as like variables, you've now got to realize that they now mean something different. This is now reads the integral of 1 over y with respect to y, the integral of this function with respect to x. So we simply have to integrate these two. Now the first one is just simple, and the second one is nearly simple because it's nearly f dashed over f. So I'm going to add a 2 and then divide by the 2. You see, these 2's would cancel out, but I've put one in and taken it out. So I haven't changed the question, and now I've got f dashed over f. We end up with this expression, but we need to be able to go all the way to y equals. So whenever you see log y equals, you can immediately write the next line down. But here's some real high-level maths now. We really need to continue to simplify this. What we're looking for here is e to the log. They're going to cancel each other out. If only that half wasn't there. Also, we have an e to the a plus b. I can use the law of indices there. Let's do that first. So this is e to the a plus b. I've turned it into the e to the a times e to the b. Now that's a constant to the unknown constant. Such a nice trick just to simply say, I'm going to rename that a. So that's the most important trick of the lot. Really nice. This awkward plus c in an index is now a simple multiplier. Now let's turn our attention to trying to force in an e to the log. This half is what's stopping it. So, but I can use a different law of logs here. This is a log b. So I'll put that into the logarithm. See how that half has gone from being a multiplier to being an index. Now I've got the thing I was searching for, e to the log. Lovely. See how much simpler it is, particularly as that half is just a square root. And finally, I can put in my starting conditions to calculate a. When x is equal to 1, y is equal to 5, well, that's just 4. Square root of 4 is 2, so a is 5 over 2. And there is the particular solution of my differential equation.